Okay, so this video we're going to look at the rational zero theorem. So the rational zero theorem states that if the polynomial f of x, in this standard form of the polynomial, degree n, right, has integer coefficients, so we're looking at strictly integer coefficients, and all polynomials up to this point that we've dealt with have had integer coefficients, then every rational zero of f of x has the form of p over q, where p is a factor of the constant term a0, right, the constant term, right, no variable, and q is a factor of the leading coefficient a sub n, right, so the coefficient in front of the highest power. When the leading coefficient is 1, the possible rational zeros are the factors of the constant term. Okay, so when this number is 1, then the possible rational, not that it's going to have those zeros, but the possible ones are all the factors of a naught, right, a0. Okay, let's illustrate this theorem using an example here. So an example would read something like this, right? So for an example, what it'd say, example, use the rational zero theorem to find the zeros of x cubed minus 3x squared minus 10x plus 24 equals to 0. Okay. All right. And okay, so we are in the state where the leading coefficient is 1. So all our possible rational zeros would be from this 24 here, right? So possible rational zeros. Okay. All right, so here I'm going to include plus or minus, right? So whatever this number is, regardless of this sign here, the factors will be the plus or minus. So again, plus or minus 1, plus or minus 24, right? Those are factors of 24. Plus or minus 2, plus or minus 12, plus or minus 3, plus or minus 8, plus or minus 4, plus or minus 6. I believe these encapsulate all of the factors here of 24, right? This is 1, so I don't have to worry about any kind of division, right? The only factor here is 1, plus or minus 1, so dividing through by plus or minus 1 just gives us back these same factors here. All right, and again, possible rational zeros, right? If you recall in the previous video, when we were dealing with the factor theorem, right, one of the zeros was given to me, right? Now, in this case, the zero is not given to me, right? It is up to me to find them, right? Now, we're not just going to guess randomly, right? We're going to guess, but it's going to come from these values, right? If it has a rational zero, it would have to come from these values, right? Now, keep in mind, it is not required that it has a rational zero, right? Some zeros might be irrational. Some might not be, might come from the complex number field. All right, they might have an imaginary part too, in which case they won't show up on our graph that we see. Okay, so let's start doing our synthetic division. Let's choose an easy one. Just wishful thinking here. Let's hope maybe it's 1. So set up the synthetic division. 1 minus 3 minus 10, 24. Right, 1 negative 2 negative 12, 12. Okay, so this is not a factor, not a zero, right? Since we have a remainder. So we're going to try this one more time. Okay. In this case, let me choose, how about 2, another easy one. All right, so bring down the 1. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 2. Add these, we get negative 10, negative 2, negative 12, and negative 24. Success here. Okay, and now I don't actually need to go further in my synthetic division. All right, I have 1, 0, 1 factor, and then I have a polynomial here, a quadratic polynomial, which I will try to either factor or use the quadratic formula to solve. All right, and here it looks like I can factor this, right? So we get x minus 2, right? X minus 4, x plus 3, right? Adds to a negative 1, adds, excuse me, adds to a negative 1, multiplies to a negative 12. And we have that exact situation here. So I have 3 zeros, x equals 2, x equals 4, and x equals to negative 3. Okay. All right. So and that's how you would use the rational zero theorem to find possible rational zeros, and then use synthetic division to try to find the actual zeros themselves. Okay? All right. So now, how about, let's do another example, right? Same premise here. So use the rational zero theorem to find the zeros of, let's see, 3x cubed minus x squared minus 11x minus 6 equals to 0. Okay, so possible rational zeros. So here we do have a coefficient here. So the denominator will be the possible coefficients of 3, which is just 1 and 3. So let's just start with 1, and let's just look at the coefficients, or the factors of 6. So plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. Okay, so those are all the possible ones. Well, that are divided by 1, right? This has two factors, 3 and 1, right? Okay, so now we look at the ones that are just divided by 3. Now some of these show up double, right? 1/3, that's not in my first list. All right, 6 over 3 is just 2, so that one's there. So 2 over 3. And then 3 over 3 is 1, which already shows up here. Okay, so we have 2 extra ones here. All right, fractions, right? Okay, so let's go ahead and we start here. So we say, okay, possible rational zeros. So we have 1. Let's start with wishful thinking here, right? 3, negative 1, negative 11, negative 6. So here we'll go here, that's 3, 2. Okay, 2, negative 9. And then here we have negative 9, negative 15. Okay, no. Okay, let's try, how about negative 2/3? Okay, so here, bring this down, we'll have 3. Multiply here, we'll have negative 2. Add these together, we get negative 3. And multiply here, we get positive 2. And this becomes negative 9. And multiply these together, we get positive 6. All right. And then we get 0. Okay, I like that. All right, so now we've found 1 0 of a cubic, so this resulting in a quadratic polynomial, so I don't need to do any more synthetic division here. I'm going to write the factored form here, so x plus 2/3, and then the resulting quadratic okay. All right. Okay, and then here we have x plus 2/3. So something that multiplies to negative 27, but adds up to negative 3. 9 times 3, that's the only one I can really think of. That doesn't work. So I'm going to have to use the quadratic formula. So the next zeros are x, negative b, plus or minus the square root of b squared, minus 4 times a times c, all over 2a, which is 3. Okay. All right. Take my calculator out. So we get x equals to 3 plus or minus. Well, here we'll get 9 minus. Here actually it should be plus, right? Since the minus and minus. 4 times 9 times 3. Okay, so 9 plus 117 over 6. Okay, and then 117 plus 9, 126 over 6. Okay, so those are my other two zeros, right? 2 being for 3, the plus, and the minus. And again, I don't think... actually, this does simplify a little bit, right? There is a factor 6, 7, 8, 9. So these add up to 9, so it actually is divisible by 9. So 126 is 9 times 14. So taking the square root of 9 is 3. 3 plus or minus 3 square root of 14 over 6. Okay, so I do want to see your answers in its lowest form, right? That includes the square roots, right? So make sure you find any perfect squares in there. Okay, and then also keep in mind here, again, be careful. There is a factor of 3 here. Now, in order for us to reduce, it has to be in both of these, right? So I'm going to reduce this by a factor of 3. So this becomes 1 plus or minus root 14 over 2. And the other one is x is negative 2/3. So we have 3 roots here. Okay, all right, not bad, right? Didn't have to look at a graph once, right? All I had was the rational zero theorem and synthetic division, and I was able to find the 3 roots. Even though the rational zero theorem only gave me 1, I was able to find the other 2, which are not rational, right? This is an irrational number. Okay, using the quadratic formula. All right, thank you.